Good day, I am Lisa Nicor and I am here to discuss with you about uniform motion. But before that, let me give you one of the myths in the world of physics. So the common misconceptions about for the people is that heavy objects fall faster than the lighter ones. So even children tend to believe in these misconceptions. So they believe that if a flat piece of paper and an apple drop from drop from the same height, the apple will fall quicker than the flat piece of paper because the apple is much heavier than the flat piece of paper. So the science explain the correct information regarding in this topic. So they say that when an object it's here when an object falls to the ground to my height, it is the gravity on the earth pulling the objects down toward the earth, and this is called the gravitational force. So um, he also added that some objects appear not to follow this rule, like a feather or the flat piece of paper a while ago, the example a while ago, because of the air resistance that slows them down, and that's because of the pull of the gravity. So let's define. I'm so sorry. So let's define the air resistance. So air resistance is a type of frictional force that acts in the opposite direction of an object moving through the air. So the force in air resistance depends on the two factors, and these are the speed and the size of moving object. Object that catches more air fall slower. So fall slower siya. But the twist in this misconception is that neither of these two will fall faster than the other object if you drop them from the same height, because according to Galileo, shows in 1589 in his Leaning Tower of Pisa experiment that the two objects hit the ground at the same time regardless of their mass. So he proved this when he dropped two spheres of different masses from the top of the Leaning Tower of Pisa. Indeed, it hit the ground at the same time. So this result was a direct violation of Aristotle's theory when he says that the object falls at a speed proportional to their mass. So this theory, once again proven by Apollo 15, David Scott, when he dropped a hammer, this one, when he dropped a hammer and a feather from the same height on the moon, and it hit the moon's surface simultaneously. So this experiment of Galileo about heavier objects and light objects corrects the misconceptions that all heavy objects will, will fall faster than the light objects. So now let's go to our topic, and let's define the uniform motions. These are And uniform motion is a type of motion in which object maintains constant speed. So it travels in a straight line as it covers equal distance and equal intervals of time. So because it moves in a constant velocity, this one, so it has a zero acceleration, and the position time graph of an object is a straight line. So to add also, the average speed of an object is equal to action speed. So if the speed of the object is constant and doesn't change any direction, then the graph for the position time graph is like this. So you can see this is straight line and it doesn't change any direction. So for the velocity time graph, you can see that it is also straight line and doesn't change any direction. So for the acceleration time graph, because the velocity is constant, so the acceleration will be at zero. So let's now give you one of the examples of uniform motions. So this one. So a bicycle makes a trip along a straight road in the north direction. During the trip, they ride for 8 minutes at an average speed of 6.2 meters per second. So how far has the bicycle traveled during the entire trip? Before that, let's analyze the given problem and find the given. So we have the time for in these are 8 minutes and average speed is 6.2 meters per second. So we can see that unit for time is not in seconds. So we need to convert it into seconds. So we know that 1 minute is equals to 60 seconds. So let's have now a new given for this. So now let's go on the solutions. And we now have a new given, this one. So because we convert the minutes to seconds, now we will have the average, the elapsed time will be now is 480 seconds. And for the average speed, we have in the given, we have 6.2 meters per second. So the formula we're going to use is this one. The distance is equals to average speed times the elapsed time. So for the solution, we will just substitute the given into this formula. So we now have distance or d is equals to 6.2 6.2 meters per seconds. So meters per second and multiply it into 480 seconds. So we just multiply this one. So you can have the calculator. We have the calculator. So 6.2 times 480 seconds. So we now have the distance, the 2,976 meters. Don't forget the unit for this one. So now this is the distance of the bicycle as he travels in the north direction. And that's all. And thank you, everyone.